I don't even know if this thing's going to record. Yep, I think it's finally working now. All right, so if we look at Lewis structures, okay? Well, it's had some issues today, but I think it's finally gone live. All right, so yesterday we talked about Lewis structures being pictures of molecules, right? We said we were going to share electrons to get to 8, and we need to talk about the steps to start Lewis structures today. I started the steps yesterday in 4th period, but we didn't get to any of that in y'all's class. So we're just a touch behind, and unfortunately this meeting prep has really set us further behind. All right. To start, you have to total all valence electrons. And I told y'all several weeks ago that when I teach the periodic table, I call them outer shell electrons. And when I teach bonding, I call them valence electrons. So now that I'm teaching bonding, I switch to valence electrons. I do it automatically. I don't know why I do it. I just do. Okay, it's a habit I don't seem to be able to break. Number 2, determine the central atom. I'm going to give you 2 rules to do this with. Most of you will be able to use the first one all the time. Okay? The element with only one atom is the central atom. And Ca is central atom. I'm not going to keep writing that out. All right, the element with only one atom is the central atom. So, if we have something like CO2, which element has only one atom? That's going to be our central atom. Okay? If we have Ci4, which one has only one atom? That's the central atom. Now, if we have something where, what did you say? That's where I'm going next. Now, change color. If all elements have one atom, atom farthest left on the periodic table is the central atom. And I hate to have to choose directions like left, knowing some of us struggle.
It's going away from the middle.
That's right, left, towards the metal, towards hydrogen. Now, who do I have to put up here as an exception? Except who? That's right. Hydrogen is never the central atom. Ever, ever. Okay? So, if I take an example this time, like NOCl, okay? You've got nitrogen, oxygen, and chlorine. Who would be the central atom? Well, looking at where their placement is on the table, who is farthest to the left out of those choices? Nitrogen. So nitrogen will be your central atom. Now, just because nitrogen's written first doesn't make it the central atom, because some books could write it ONCl, and N would still be the central atom. It doesn't have to be written as the first element, okay? It's based on who is farthest left on the periodic table. Everybody with me on how we determine the central atom? We're going to get there. You can only have 2 atoms or 2 electrons on it. And we got to have 8 when they share. Hydrogen can't have 8.
My responsibility is to lose. You know, I'm right next to you.
Mhm.
But you guys, okay, I kind of Tuesday or when I was thinking, you have 5 minutes.
Yes.
I kind of did this together, right? Yeah. I was thinking, I work.
Now we have a 5-day week.
But like, we're almost halfway done with the week.
We are. Thanksgiving's one of my favorite holidays. It doesn't matter really. Yeah, bring Christmas. I'm home more about. All right. Yeah, I'm not home Thanksgiving, so I don't care about that. I'm on the road the whole time. All right, number 3. Place all remaining atoms around the central atom. Sometimes you will only have 2. Put both of them around. It could be a straight line, they can be up and down, they can be in an L shape. Sometimes you'll have 4. Sometimes you'll have 6. Whatever it is you have, you just put them around the central atom. And then step 4 is the one that will cause all of the problems. All right, using the electron from step 1. Place them around each atom until they have 8. If they do not rearrange until they do. Don't I usually do that? People doubt myself. Now, what I put in the little yellow bracket are the multiple bonds, right? That rearranged part is the double and triple bond. The part that's not in brackets, we're going to do with a single bond. But the part I put in the yellow bracket will be our double and triple bonds that we'll talk about towards the end of class. Okay.
Where's it get better? I'm getting better.
I really love that fifth grade, but that was really fun. I thought it was.
It's hard to go by.
I flew by it in like 3 minutes and I really loved it. But I really hope that's good.
I don't know. It could be good. I don't think it could be hard. If you could do the opening, you could do the quiz. The opening was the quiz. In case y'all didn't notice that.
I know, it was really easy, but then I was like, that scares me that it was like having.
Yeah, I wasn't there for that.
Yeah, you are.
It wasn't the exact same.
It wasn't the exact same compound, but the rest of it was the same.
I was waiting.
You there,
for
Shy?
my definition, and then I was like.
Shy, you caught up?
Yeah, Mama, when y'all didn't know about it. I heard, I think.
All right. So, step 1 said to do what? All right, count up our valence electrons. We're going to do that the same way that we counted up mass. All right, for some of you, this will cause huge issues when we review for the benchmark. All right, how many C's do we have? How many I's do we have? Now, we're not putting in a mass here. We're counting up valence electrons. There's 4 for C and 7 for I. Okay, y'all don't have to fight over who's going to give the right answer. You both have the right answer. Now, my question is, does everybody else in the room know how Queen and Daniela got 4 and 7? Because if you don't, we're toast. Okay? Dead at step 1. So if you don't know how we got 4 and 7, you need to be brave and say, well, I don't know how we got 4 and 7. Yes, I can. Now, you remember back when we studied the periodic table? I know, it was so long ago. Okay, it's on the test Monday. You see this column right here? So group 1, it has how many outer shell electrons? 1. Column right here is group 2, it has how many outer shell electrons? 2. We jumped the transition metals, and group 13 has how many? Group 14 has, group 15 has, group 16 has, group 17 has 7, and group 18 has 8. Carbon is in group 14, so has how many? Group 4. And group 17 has 7. So iodine has 7, carbon has 4. Everybody with me? All right. School this afternoon to buy my first down pack. 4, 28. All right, 32. But I don't have to escort them to the bathroom either. All right. So you know what's going to happen? They're going to get busy. And you know who's going to wind up taking boys to the bathroom? Y'all. Teachers going to wind up doing that crap. Now, no, they'll be good. Teachers don't play for each other.
That's a fact, like 15 years.
Alright, so, oh, just be careful. If they come in here and they say, any boys need to go to the bathroom, same things apply. If you say, yeah, I gotta go, it's a bathroom pass. It's not a freebie to the bathroom. It's just check it. That's what they're gonna do.
Yeah.
Yeah, that's that way, that was just explained to me about that. They're gonna hold my hand.
Yeah.
So, if they say, during my class, do you need to go to the bathroom? And Ethan says yes, and I go over here and I look at Ethan's number of bathroom passes, and Ethan has, let's see. Ethan has not been to the bathroom, so he still has 15 points on his last test grade of this quarter, and he says, yes, I'd like to go to the bathroom. Ethan gets a deduction of 1 bathroom pass. It's not a freebie. Okay, so let's just be clear on that. There's no freebies to the bathroom. You may go, but the same rules apply. Gas laws, at least 2, and benchmarks, so 3. Okay? Getting there. All right, so how many, or what's the central atom? Got to do that first. Carbon. There's only 1 C. So, since there's only 1 C, central atom is C. Step 3. How many I's do I have? 4. So I'm going to draw them around the central atom. I'm going to draw 4 of them because there are how many I's? It does not matter really where I place them. I generally just draw them around. Okay? A dot diagram on steroids. We haven't put the dots in yet. So, step 4 says, use the electrons from step 1. How many did y'all just tell me there were? I'm putting 32 dots. Okay? 32. No, hush. I'm placing them around each element until they have 8. Now, I told you these were multiple bonds. We're starting easy. Okay? So, those of you writing with ink, stop writing. Okay? Those of you writing with pencil might want to wait too unless you want to erase. 1, 2, 3, 4, 5, 6, 7, 8. Now there's 8 of my 32. I need to put in more electrons. I don't have 32 in that dot diagram, do I? So where am I going to put some other dots? Around the eyes. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20,
Oh, they
21,
said,
22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32.
Wow, this is.
Now, when I finish drawing those, check to see if everyone has 8. 2, 4, 6, 8. That is good. 2, 4, 6, 8. It's good. 2, 4, 6, 8. 2, 4, 6, 8. And lastly, my C. 2, 4, 6, 8. Everybody has 8, which is the first thing I need to check. Does everybody have 8? Yes. Number 2, did I use the 32 dots that I added up in step 1? Yes. Those are the 2 rules I have to meet. Everybody has 8, and I used my 32. Now, don't draw yet. Tyshawn said, oh, they share them. So how do I show that they're shared? So right here, instead of drawing dots, we draw a line to represent that they're shared. So get rid of the dots and make them a line.
this is so familiar.
Now, each line represents how many dots? 2. Now you may draw. Okay? Okay? Everybody got it? Now you're right. I got a couple vocabulary words you need while you're writing. Because you know, can't do it without a vocabulary word. This is called a lone pair. Some books will call them unshared pairs. Or, just because you know we don't have enough names to confuse you, non-bonding pairs. It all means the same thing. All right, they're electrons not involved in a bond. I will call them lone pairs 9 times out of 10, because that's the way my chemistry teacher taught it in high school. It's what I have done since I learned it that way. But unshared pairs and non-bonding pairs mean the same thing. Now, this, with the line then, is called a bonding pair or a shared pair. And I'm not even going to write a definition for that, because you guys are smart enough to know that if that unshared pair and non-bonding pair is not involved in a bond, what's the other one? It's involved in the bond. So the electrons are shared. Huh? I don't ever noodle that way. But I'll consider myself a chemist. Some people live, eat, and breathe science in their free time. Thornhill reads science stuff and tweets that crack out. I don't ever read science stuff in my free time.
Every
Like
single
ever.
every single time like I talk to her or something, it's usually unrelated to biology.
Never. If you and I talk, we can have a political discussion or something like that. I never
Every
read.
time I go to her house, she just has like science magazines.
Never. You will never find a science magazine in my house, like ever.
Like after the
Oh yeah.
she was just laying there reading about her baby. The last one, and everyone can remember I was talking about that chapter and how my dad was doing Margaret, so I want to gave you a lecture on why I sweat.
Yeah.
I can just imagine that.
You will never have that kind of conversation with me, like ever.
Whatever you're doing, I love it, but actually,
No. You never have that fear if you and I ever meet up outside of this class. All right, let's draw water. Like ever. All right, so we draw water. All right, I picked this one because it's an exception. Because hydrogen is an exception, you need to know it. First of all, how many H's do we have? Okay? How many O's? How many electrons and hydrogens outer shell? Did you say 3? I know Spanish is not my native language, but I'm almost positive that's 3 in Spanish. Okay. It's been a long time since ninth grade. Okay. Oxygen has how many? So we get 2, we get 6, for a grand total of 8. All right. So from there, that's a whole lot less electrons to have to draw than 32. All right. So who's my central atom this time? Okay. How many O's are we drawing, or H's are we drawing around it? Okay. So this time there's only 2. This is why I said earlier, some of you will like to draw it in a line, perhaps straight out like that. No, there's nothing wrong. Some of you might want to draw it like this. Nothing wrong with that either. Some of you might want to draw it in the nail. Nothing wrong with that either. You pick the one that you like. I don't care. It can be wherever. You just need 2 of them around the O. Okay? H cannot be in the middle because it can't be a central atom. Remember, when I said the central atom rule, who can never be a central atom? H. H can never be in the middle. That's the only thing you can't do. Okay? But it doesn't matter where you put the H's around it. Okay? So, from there, we need how many electrons? Okay? So, I'm going to, instead of drawing the dots first this time, I'm going to put a line here and a line here because we already know what's going to happen between the H and the O. They're going to share. So, 2 are going to share there, 2 are going to share there. Now, H is an exception. H has a configuration of 1s1. How many electrons can an S sublevel hold?
2.
It can only hold 2. Okay? It only holds 2 electrons. So the maximum electrons that hydrogen can have is 2. Okay? 2. So H never has dots or multiple bonds. Okay? Ever. So once you put that single bond on H, H is done. It has the 2 electrons it can have. It can't have anything else. It's got the 2 electrons. So where are the rest of the dots going to have to go? Okay? So there's 4, 6, and 8. And it's finished. H can never have dots. Can only have 2 electrons. What I just said. You cannot put any on H. What I just said. H never has dots.
So wait, basically, do we have to draw a line?
Yes. Yes. Say what now, Alexa? What'd you say, Alexa? Okay. All right. Now, before I give you a chance to practice, I do want to draw a polyatomic ion. Now, we ain't got to the hard part yet. This is the easy part. Now, a polyatomic ion is just a group of atoms with a common charge. For example, let's say we have PO4 with a -3. Okay? That would be a polyatomic ion. Now, drawing a Lewis structure for it, though, doesn't work any different. No, it doesn't. The only thing that's different is step 1. Adding up the electrons. Because of the -3. So, how many P's do we have? How many O's do we have? Okay, 1 P, 4 O's. How many outer shell electrons does P have? What group is it in up there? What? Stop trying to do it without looking at the periodic table.
I tried. 5. I was close.
All right, oxygen has how many outer shell electrons? 6. So 24, 5, you get 29. Now, I will tell you in a first year class, you are not going to get an odd number of electrons. Yes, odd number of electrons do exist in chemistry. You can have an odd number in a Lewis structure. The odd number goes on the central atom. This is not an AP class. It's a first year beginning chemistry class, even though y'all are an honors class. So if you get an odd number, that should tell you you have a mistake and you need to fix it in a first year class. Please. Yes, that's where I'm going. Now, but if you have an odd number, you should know, oops, I have some mistake and I need to fix it. Is everybody okay with that part? Yes. Yeah, I know, you know. All right, so fall back on knowledge you guys have. What do you know that this means? That's right. You gain 3 electrons, right? So if you gain 3 electrons, what are you going to do right here? If y'all gain 3 electrons, what are you going to do right there? You're going to add 3.
You're gonna get 32.
You're going to get 32 electrons. That's why Queen was looking at me going, isn't this still going to be odd a second ago, because she was adding wrong in her head. All right, so now the steps are the same. Who is the central atom? Because there's only one. So phosphorus is the central atom. Okay? How many O's are we drawing around the central atom? Drawing 4. And how many of these blamed electrons do we have to draw in? 32. 2, 4, 6, 8. At least I got 8 done with the lines. That makes it nice, right? I'll do another 24 there. So there's 10, 12, 14, 16, 18, 20. 32. Now, last step. Okay? Yep. So, double check before we do the last step. What were the 2 things I said we had to do? So check yourself and make sure everybody has 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And make sure you had how many? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I got 32. Everybody has 8. You'll be surprised how many of y'all can't count, by the way. All right? Last step. All right, now I don't have enough space for my -3 up here. Okay. You add brackets with the oxidation number to a polyatomic ion. That's to tell us you added some electrons in. Okay? Because if you don't draw the brackets with the number, we would not know it's a polyatomic ion. Technically, yes. Technically, yes. Say what? Yes, it goes on the right side. Technically, it should be more like here. I'm just out of space to write it there. But it's fine where it's at. If you wrote it there, I wouldn't take off. Okay. All right. Now, we need to practice what we've done. Okay? I'm just running out of time to do the multiple bonds, which we need to get to today. So I'm going to show you a multiple bond, and then we're going to practice. Now, I will do more with multiple bonds on the YouTube video, which I will also record fourth period, but it will be at the very end of class. So those of you who need more multiple bonds, watch the YouTube from fourth period today. Okay? But I'm going to show you it now. No, you will not have a quiz tomorrow. Your quiz is on Thursday. All right, your multiple bonds are your double and your triple bond. And I'm just going to show you one because you're going to run across it in homework. As an example, we're going to do your favorite biology compound. Oh, we're gonna do CO2. We're gonna do an easy one. We're not gonna do, glucose. No. CO2 is much easier. We're not gonna do a carbon chain. No. Those are carbon chains. Not part of our curriculum. All right, CO2, same steps. Okay, nothing is different. What's the first thing you do? So who's my central atom? Oh, I'm jumping ahead. I already just passed my head. Sorry. We back up. Yeah. Sorry. How many C's? How many O's? How many electrons in the outer shell C? And then O. So we get 4,
I was the opposite, bro.
12, 16. All right, so we got 16 this time. Now who's the central atom?
Carbon.
Okay. And how many O's have I drawn? All right, since I did L shape this time, I'm going to do straight out this time. All right, since I had an L on the water, I'll draw it straight out this time. You can also draw it straight up and down. It does not make any difference how you draw the two out. All right. So I'm going to draw my bond here to show sharing and my bond here to show sharing. And that gives me 4, so I still got 12 left to go. All right, so that gives me 8. I got 8 to go. You want to do 6 and 2 or 4 and 4? 4 and 4. Okay, we can do 4 and 4. 4 here and 4 here. Now, this is the first one we've had that what's the problem? Everybody doesn't have 8. Now, this is where we cruise back to my steps that I put in brackets. Okay, this is the first one we've had where everybody didn't have 8. So, we cannot add any more electrons. Okay, it would be really cool if I just said, oh, dang. I got the right number now, but how many do I have? I can't do that, okay? I'm only allowed 16 dots, which is why I said earlier, when we were doing this, I had to check to make sure I had the right number, and everybody had what? 8. So this time, I've only got how many to work with, and I have to make sure everybody has 8. So I can't just drop in 2 more here and 2 more there. No. All I can do is rearrange them to make them share. No triangle. I'm going to show you. It's not hard. So, who has 8? Carbon. So carbon is going to be ever so kind. Think back to elementary school when someone had something and you didn't. And back then, it was second nature to say, here, let me help you. Or here, have some of mine. Okay, now we're much more standoffish and less likely to do that. Okay, so carbon's going to say, where can I put my electrons to help you out? If I move them over here, now who has them? O has them, and C only has how many? C has 6. So moving them there only helps out O. So here is where both of them have them, right? So those 2 dots that were right here that C had, C is going to take its dots and it's going to put them here. Because if they're here, now O has it and C has it. Okay? So O has 2, 4, 6, 8. And C has 2, 4, 6, 8. Wow. So, what is C going to do with these 2? Same thing. It's going to take those 2 there, and it's going to put them here. So it has 2, 4, 6, 8. So now, everybody has 8, and I still have how many? 16. Okay? Now, I also want to show you something else. Yes, Queen? Yep. All right, now, I asked you at the start of this, when we had these 8 in, I said, did you want to do 4 and 4 or 6 and 2? And Ethan said 4 and 4. But some of y'all are probably thinking, why don't we do 6 and 2? Okay, let's do 6 and 2. Okay, got 8? Got 8? Got how many? Got 4. 2 and 2 is 4. Can I make this work? Sure can. Take these off and put them where?
Ms. Wall,
Yeah.
can I have Jordan back to guidance?
Sure.
Thank you.
I thought they were going to call my phone.
Or nobody ever understood me. It's all work. It's all over the stuff. Right? Now, how many does it have? How many does it have?
No, it had 4.
Total. 2, 4, 6, 8. So that still has 8. 2, 4, 6, 8. Everybody's happy now except this one. It only has 6, right?
One more line. One more line.
Oh my God.
One more.
So either way, it would have worked, whether you went 4 and 4 or 6 and 2. These have a name. These are called, let me see if I can fit it in, resonance forms. Both are correct, and you would get full credit for either one. All right, what's your question, please?
So there's a triple bond between the two of right?
Mm-hmm.
Triple bond. So the original question when we had, one triple bond, we had. One of them has to be. Or is it always usually that way?
Yep.
Will there ever be, it can't stop all, will there ever be like 5, elements where you have to put it around the flag?
Say what?
There you go.
You have something like PCl5, you just draw P, and you have 5, 2, 3, 4, 5, chlorine. This is called an expanded octet, and we're going to work with these tomorrow with geometry, and you may have to draw one, for example, tonight, but it's called an expanded octet. You have more than 8 on the central atom. This actually has 40 electrons in it, and you just have more than 8. It will look like that.
Oh.
Okay? You can even have up to 6, because we're going to do one with 5 and one with 6. This one has 5, and we're going to do one that has 6. Why are y'all packing up 5 minutes before the bell? When did we start that crowd? Oh, that's some kind of new rule I wasn't made aware of?
Yeah, we had to go 10 minutes before 5.
Really? Since when? Oh, is this part of the new bathroom policy? I need to stop in case someone comes up and says, hey, any dudes got to go to the bathroom now? Really? That's a new one.
Guys,
You know what I was saying? I was like, no, all know that you can't stop all of us. Can I get a break? Okay.
Not talking, he's talking about homework,
No,
no.
I was talking about like, in the auditorium.
Directors does not take precedence over fly.
No, I'm talking about in the auditorium, but they can't stop all of us.
let's do it. Let Taylor, everybody.
I'm like, I feel like, they can work, they $600.
Yeah.
I can see,
I was like,
I can see
wow.
like,
Yeah,
you know, in like kindergarten, they make them hold each other's hands and lie. They would go around to all the classes, yell and all hold each other's
If you look at what I did, I need to alter the direction. All right, on the directions, we tell you to draw the wood structures, tell me the geometries and the polarities. You guys don't know how to do geometry and polarity yet. We're doing this.
Who don't?
Really?
Yeah.
So you can tell me the geometry of that molecule. Right?
Not that one. This one is yeah. Oh,
Go ahead. Tell me geometry number 1. I can't wait.
Number 1 is the sphere. Cool, right?
Alright, you're drawing the Lewis structure from 1 through 14. Because tomorrow we're using these Lewis structures as our practice
for the geometry and determining if it's polar or non-polar. So if you don't have any structures, when I say find the geometry, am I gonna wait on you to go back and draw all these? No.
That's the two things. Well, I need a bigger binder.
So 1 through 14.
Right, I ran out of room.
I know, I can't put my notebook in here.
I can't put it on paper.
I can't put my notebook in here.
Then I would suggest you go buy a bigger binder.
Yeah.
We're